Welcome back to Chuck's Electronics and Robotics Workshop. It's been a while since I've been able to talk to you guys. Anyway, I want to share something with you today. We're going to take and we're going to build a squeezer or a robotic gripper. We just simply take one of these plastic tweezers and we're just going to hook it up over here. I built up this little battery box. You can just put a plus and minus onto there. This has a forward and reversing ability. So here we can squeeze it, or we can keep it continuous, which I really like because then you don't have to have a reversing circuit. And the cool thing about it is, let's say for instance we want to pick this up. We can pick it right up and then keep pressing it. If it's too thick, it won't work, but if you have to reverse it. But if you have something thinner, like say this propeller, let's set this up like this, you can grab it and then keeping the same polarity on the motor, you can release it. So you can actually use it for picking up, but if you get it too thick, it's gonna jam, and then you'll need a reversing circuit. But if you're just picking up thin items like that, there's no problem. Let's take a look at how it's built. Okay, basically what I did was I modified a servo here. I like using the servos because they have a nice, neat little gearbox. And then all I did was take a servo horn and glued it into a soda cap, pop cap, whatever you might want to call it, and drilled a hole right through so that it could be mounted to the servo. Now you might be looking at this and saying, well, that's pretty cool, but I don't have a piece of plastic like that. Well, that's okay. You can use popsicle sticks, cardboard, whatever. Just if you're going to use cardboard, just make it strong enough and stout enough. Now let's test this one out. This one basically uses a water bottle cap with a servo horn that's glued in there, just like that, and 5 centimeters across. You can just cut these pieces out. These are actually, I think they call them craft sticks. And watch the action. I have it set so it's a cam that closes in and then locks in place wherever I put it. And that's kind of a nice little feature, because a lot of times servos will bounce back and forth and open and close when you really don't want them to close, and because of the different stresses that's put on there. Now let's do this. Okay, so let's pick up this guy. Whoops. Pick him up. And now with the ability of this type of setup that I have, there's actually a flexing that occurs on the water bottle cap, whereas on the soda bottle it's not as flexing. So therefore we can even pick up larger diameter items, keeping the polarity the same way. There you go. Okay, so basically we just hot melt glue the servo right on here, and we set it up so that the tweezer is squeezed, and we hot melt glue here. It works really good. It's pretty cool. So I hope this helps a lot of people out with some different ideas. You can also, if you have a 3D printer, you can make your own cam like I did here, but you really don't need that. And you can glue on your servo horn. So it was great having you back, and I hope you enjoyed this, and I hope this goes into somebody's robotic design, because it's really cool, because it just uses your regular polarity. This is actually a split battery pack, so really in reality I'm only running 3 volts into the servo. And look how nice and strong that is. Let's see if we can pick up the tweezers. Yep. Squeeze it, hold it in place, and release it. Again, There it is. So you can actually pulse it to wherever you want. And if you do have a reversing circuit, of course you can open and close it too. But it does open and close automatically just by virtue of the cam. Thanks for joining me. Have a great day.